Hey guys, welcome to week 4 of DSGN121, where we look at Fusion 360. This week we're going to be expanding on adding a few other of the 3D tools that you're going to be using quite a lot, and looking at as well some of the basic way in which you would make a assembly of multiple bodies in a single part. And later on this quarter, we're going to talk about making an assembly with multiple components. So what the difference is between that is right now I am in a singular component. If I right click this, I can do a new component, and that will turn this into an assembly. That is a bit more complicated, and so we're going to look at that later. For now, what we're going to look at is, instead of that, we are going to be looking at, within this singular component, we are going to be joining together multiple bodies into a one assembly within this component. So I'll just do a quick example to show you what I mean by that, and then after I've talked about kind of a little bit about multiple bodies, how that works, different ways you can add or subtract and create new bodies and things like that. After that, I'm going to look at a couple of the different tools, and the way I'm going to be showing those is by actually modeling a couple different things. Your exercise for this week is going to be to model two simple objects, and you can choose whatever those two objects can be. And I've chosen a paperclip holder that I've got here in my hands, and this coffee mug sort of thing here that I've got. So those are the two things that I'm going to be modeling. And basically what I would suggest for you as you're picking the two things that you're modeling is just pick something that you can kind of achievably model. So something that's not too complex and has fairly simple geometry to it, and is something that is going to use those skills that we're learning here. And if you need help picking an object, or not sure if your object is going to work or not, just reach out to me and let me know, and we'll talk more about that. And then we're also going to be looking at our project, so our first project for this quarter, and talking about how to achieve that as well. And then lastly, there will be a quiz that will be posted on D2L, in which you will download it, fill in the answers, and then submit it to a Dropbox. And because we have 3 different things being assigned this week, we're going to forego a discussion this week to just help you have more time to work on those other things. Okay, so with that being said, let's go ahead and create a couple objects. And so first I'll just create something nice and simple, just a 10 by 10, and I'm not going to fully define this just for the sake of example. So when I have created a sketch and extruded out a cube, I get my body folder and my sketch folder, right? If I go and I create another sketch, and this time I want to sketch on top, and notice here, before we were using the planes, now I can actually use the 3D geometry that I've drawn here, and I can actually use that to draw my next sketch. So for example, if I want the top of this to have something on it, I can actually click the top of this and draw immediately right on top of this. And the advantage to that is that it will allow me to, when I extrude this, it will automatically extrude it relative to where that sketch plane is. Instead of me drawing it down here and then having to use some sort of offset to get it to appear up here, I can actually just extrude it, and just like that. And then what you'll see over here is the next part that we're going to talk about, which is the operation. So this is where we can either join, cut, intersect, new body, or new component. So if I click join, what that will do is, you'll notice over here on the body folder, it stays as one body. So I now have 2 sketches, and they are extruding to the singular body that is right here. Okay. Now, if I were to instead edit this and make this a new body and hit OK, I now have body 1 and body 2 as two separate bodies. So these are completely independent. They're not actually joined whatsoever. Something there to note is if I try to fillet, notice what happens when I click that edge, right? And we haven't talked about filleting yet. That's going to come up in a little bit here. But this is three-dimensional filleting. You can see here how it's rounding that edge. Okay, that's what happens when they're two separate bodies. It's starting to round this edge up. But if these are one body, and I go to fillet that, it does the opposite. It acts as if they are fused together, and it's now creating a fillet between this surface and this surface. So it's the complete opposite. So it does matter how you do it, and the way that you need to think about it when you're thinking about, do I need to join this to a body or does it need to be its own body, is think about it in the way that you think about the objects in real life. If the object, for example, when I model my coffee mug, the whole thing is one contiguous object. There are no parts, there are no connectors, there's nothing going on with that. So that is all going to be one body. My paperclip holder, on the other hand, if you've seen those before, familiar, and you'll see when I model it, that is made up of two different parts, and technically it's probably actually made up of 4 different parts, but I'm actually just going to model 2 just to make it easier and simpler. But that is made up of 2 different bodies, so all the features that I do to one body are going to be there, and then all the features that I do to the other body are going to be on that body. So I'm going to have 2 completely separate bodies, and I can have as many features as I want on the single body, and it's just basically making that a single part. So kind of the way that I'm basically saying that you guys should be thinking about this is that you should be thinking as the bodies are one part, and as if you were to manufacture it, would that be one part, or would it have to be required to be assembled to a second part? So in this case, I'm just going to add a few more features to this to just kind of further drive the point home. What this is another circle that I drew, and this time I'm going to show the cutting operation, which is where instead you are creating the sketch, and then I am actually going to cut through the same body. So this is still body 1. We haven't done anything else. This is just the single body. And I'm just going to go ahead and keep adding features to it. Go into something like that. Add another cut in there. Go back into my fillet operation here. That's fine. There. So basically we'll just leave it there at that. So now you can see that I've got 4 sketches that make this up, but it's still one body. Okay, now if I was going to want to say, hey, I want to actually have like a pole that goes through here, I can go back to one of these other sketches that I've already used, say this one here, and I can do another extrude using, and I guess I need to show it there, show that sketch. I'm going to come out 2 millimeters this way, and I need to change my direction to 2 sides, and I'm going to come out another 2 mil. I guess that would be what, 10, 11, 12. And this time I'm going to do new body. And so what that is now is I now have my overall piece here, this one here, what I put with all the holes in it, and then I have my rod, which is going through it. So that is two separate bodies that are interacting with one another. And so that's kind of the way that I want you guys to think about it. And as we work on our different things here in just a little bit, hopefully it'll make a little bit more sense, but let me know if it doesn't. But basically, rule of thumb is if when manufacturing, it's all one piece that's all fused together, like a plastic extrusion piece or something machined out of metal or wood, it's going to be one body. If it is something that requires some sort of assembling, like a pin inside of a slot, those need to be two separate bodies to imply that there are two objects there. Okay? And again, this is applying currently with the knowledge that you guys have to this modeling method. And it will change as we move on, and I'll explain that later. But for now, what you just need to understand is right now we're modeling within a singular component, and each object within that component is going to need to be a new body. Okay? And one other thing I'll just show real quick here is I'm just going to modify the second body here just to show. Oh, come on. Okay, there we go. So just to show there that I am not creating a new body or anything, but I'm just editing the other body independently. Just to show as a quick example there. Okay. So I'm just going to go ahead and delete all of that. And yeah, we'll go ahead and start. I'll start with the coffee mug, just because that one will start with our first new 3D feature that I have not talked about. That is an important one, and that is called Revolve. And so what Revolve is instead of creating a straight extrusion where you have a profile and you're extruding it parallel with the profile, we are actually going to create what is basically like a cross-section profile. So if you can see here in this example, that little, whatever this piece is, if you were to essentially cut that thing in half and look at the face, that is what that blue profile is it's imagining that you're taking a profile and then you are revolving it around some sort of axes, 360 degrees, or to whatever angle that you want. So before I do my coffee cup, I will show you a couple examples just to hopefully help better understand what's going on there. So the first thing is, let's start in the front plane here. So that's what I'm going to sketch on. And what I'm going to do is I'm just going to create a construction line here. And I was noticing here that they have updated this. So now there's construction and center line. And the difference between the two, I'm not entirely sure. But technically this is a center line. So that is what I'm going to click for that. And maybe it's, oh, maybe that's what it is because in that way it's just doing it once instead of always staying on construction. But basically I'm going to imagine that this is the center of my object. So I'm just going to do a very simple thing here, and that's just going to be a square, or sorry, a rectangle here. And what I'm going to do is just go to Solid, Revolve, and the profile is the one that's selected here in blue, and the axes is basically going to be the center point right there. So if we imagine that that's the center point there, we can see the revolving there. So this is the most simple example here of how that's working. Is you can see that that's the cross section of what it looks like there, and there is the revolve. Other things that you can adjust here are the angle to up to an object or full. So if I did full, it would just automatically do the full revolution. If I do angle, I can actually change how much of this I want revolved. And that's a great little almost like an animation of seeing what's happening as it's revolving it, is it's taking that profile and sweeping it around that axis, just like that. Okay. You can also make this one two-sided if you wanted to have some sort of offset entity there. You can make it symmetric, so it goes a certain distance either direction, or just one side, which is what I was showing before. And again, if you just want that to be a full, just hit full and then click OK, and we've got our new body there. Okay, so let's try a couple different other profiles. So I'll go ahead and edit the sketch. And instead of that, I'm going to do this. And you know what, just for fun, I'll go ahead and add in something like that. Oops. Let's try that again, just to see what happens. Okay, so solid, revolve. And I don't have to do this every time. In fact, the reason it's making me do it again is just because of the way I deleted this, and I actually just meant to go back and to edit the sketch. So you can see there, and in fact right now, because that sketch is still showing, I can actually edit it in real time and see how it affects my 3D object here in real time. So let's make it a little more interesting, and let's actually flip this so the square is on the inside. And I definitely encourage you to play around with this to just better understand how this is forming objects here. So you can see here I'm already making something that looks like a vessel you might drink from. You can see here how that's shaping that object there. I can take that here, make it taller, make it shorter. Obviously, I'm limited to the points that I created. So if I want to add more points or change the geometry at all, so for example, if I want, let's just say, let's do this. I want this to be offset a millimeter. Hit OK. And instead of that being horizontal, we'll connect that. And we'll connect that. And right now I have not been doing a good job of defining stuff, which is mostly just for example's sake. So there we go. And then now I can, if I adjust one side there, you can kind of see how that's affecting it. Oops, and I broke the sketch. Super interesting stuff. So yeah, it's all based on how you draw your sketch. So if I wanted to create a coffee mug, how would I go about doing that? Well, first of all, this one, unlike the examples that I've been showing, this one actually needs to be solid on the inside. So I'm still going to draw this here. And I'm going to start by drawing a rim of it. And technically my rim is actually rounded. So I'm actually going to draw a 3-point arc. Is this one beginning, end, start there? Okay, and I'm just going to actually measure my cup here because I want it to be look as accurate as possible. So it looks like the radius of it's going to be about 6.6 wide, like so. So I could put 6.6. I guess I need to delete that there. So that's about the rim of the cup thickness. So I'm going to bring this around like so. Then I'm going to get the general width of the top of it. Call it 87.5. So from here, and this is something that's important to note here about using a center line, is it actually allows you, when you dimension something relative to a center line, to dimension as if it was on the opposite side as well. I say 87.5. Yeah. And just a quick example of that, of the difference between the two. So if I just create a normal construction line like so, and I have my circle over here, and I'm dimensioning relative to this, it's going to dimension it straight to the center of it. But if I dimension it to a center line, it'll actually dimension essentially as if there was a mirrored opposite on the other side. So it gives you the whole diameter. So it's a way of thinking about it is with a normal construction line, you're measuring the radius, and with a center line, you're actually measuring the diameter. So that's how tall it needs to be at the very top. And then at the bottom of my mug, call it 54. So at the bottom of it, and I'm going to kind of start to draw my curve here. Oops, I don't want a construction line. So something like that, and then I'm going to draw a straight line over to the center. This distance, so from this point over is, shoot, I just said it and then I forgot. Called 53. About 53 is where the bottom of it's going to be. Okay, and I will go ahead and take this line and offset it 6 millimeters. That'll line it up with about there. And with this curve, I'm actually probably going to have to do something more like a tangent arc. So it's going to come around to there, and then each one of these is going to be tangent to one another. So very, very, very simple shape here. Probably not exactly accurate to what's going on with the cup, but works nonetheless. So then this is going to come over to the center line as well. Notice how that's kind of not a very smooth transition there between the two, nor is that one there. That's fine because I can actually smooth that out with some fillets later. And it's still showing blue, so we can kind of try to drag it around and see what happens. Oh, you can see it starting to smash there. That's probably due to the nature of my splines here, which are not really easily definable. So I'm going to call that okay. And I definitely am not marking people down if their splines are undefined, because that's pretty tricky to do. So let's go ahead and leave it there, and let's see how it looks when I revolve. Only other thing that I'm really missing is technically I should probably close that side off. So let me just go ahead and do a line right there. And then we'll go ahead and do a solid revolve. And there we can kind of see how that's looking. So I can tell you for starters right now, the top of this lip is actually not perfectly round. It's more of like it comes up and then kind of tapers off. So I'm actually going to fix that because I am like that. So I'm going to do another fixed point spline. And I'll probably do something like that to start with. Kind of go normal to this. And what I'm going to do is I'm going to take that and that, make those tangent. Then I'm going to take this one and make them tangent. And then what I'm going to do is I'm going to kind of play with my handles here till I get something that looks a little bit more like my mug does. So those are tangent already, but see how it's kind of squirreling off on me. So let's try something like that. do a revolve. Looks a little bit better, still not great. Looks like it needs to come quite a bit more down. So I'll edit that again. And probably bring that more like there. How's that looking? Yeah, that's about right. So other things that we can do, if I look at the bottom, it looks like technically there's actually a little bit of an indentation in the bottom. So this actually rounds and then comes up into the bottom. So again, I can go back and edit my sketch. So instead of having a flat there, there's going to be a flat a little bit higher up here, like so. And again, this isn't any sort of, I don't have any special knowledge. It's mostly just I'm observing what I'm looking at. And I can see that it's approximately 3 millimeters of a indent here. That seems quite a bit. Is that really how far up it goes? It's more like 2. Okay, that looks better. So it's like a 2, and then all I need to do is just try to connect these from like a curve into another curve. Oops, I keep doing escape. So I'll hit OK on that, and what I'll do is I'll drag that in, drag that up. Go ahead and make these tangent. Raise that up, and again, I'm just doing it in, I'm kind of eyeballing this at the moment, just as much as I can. Something like that. Take those 2 lines, we'll make those tangent. Currently, I'm not really dimensioning anything. I'm simply just going off of eyeballing. My main dimensions here. Oh, you know what I'm forgetting? The height of it. So there are some things that you do want to use real dimensions for. So the height of this is about, we'll call it 60. It's just a bit under 60. And what I'll do is I'll create a point somewhere up there. And I'm going to say from there to here needs to be 60. And the point was supposed to be coincident to that. It does not like that. This is where not defining things can get you into trouble. So let's try dimensioning. Again, I'll try to create a point. So from there to there. Okay, that's fine. So what that little error was saying is that this is a driven dimension, and what that means is this point is already defined because it's coincident with this curve. And by me making this a driven dimension, all it will do is, you can see here, it's just displaying the height of it instead of actually making it stay that height. So that's fine with me. And I'll just come back here and I'll just drag things around and adjust them until it looks correct. So that's just shy of 60, not too shabby. Curvature looks okay. Not my favorite. Probably something a little bit more straight like that. Something like that. And I've got this 53 dimension is actually really more of where this should be. So what I'll do is I'll actually bring that back. Do something more like that. And try and just move these points around. Looks like I've got like an extra point in there. So I'll just delete that one. That's better there. Okay. So again, this is all just kind of using my powers of observation to look at the object that I'm doing. Again, this is going to be your first kind of designing something in this. So take your time, play around with stuff, try to get it as best as you can. And yeah, that looks pretty decent. So I'm just going to hold up my real one to it. Look at the curvature of it. It looks like my curvature is a little, it comes out, and it really needs to go more like straight down and then curve. So we'll make a couple other little tweaks to it. So I'll take that, make that a little more straight down, and then curve. Yep, that's about right. Okay, one other thing I'm going to do to this is going to fillet this inside, and this will be my chance here to talk about filleting. Not a great example of filleting in terms of you're not going to see a huge difference here. But essentially the way that this works, it's not the most intuitive in my opinion, but essentially you select what you want to fillet, and if you want to fillet multiple things, you have to select multiple things first and then adjust the size. So in this case, I'm going to select here. This is the only thing that I'm filleting, and I'm just going to adjust that size. I'm going to make it as kind of smooth as I can. I'm going to look at it from the front. It's actually quite curvy on the inside. Probably something like that. So I'll just leave it like that, 26, hit OK, and then now it's filleted on the inside there. And let me just show you a quick example over here of a simple square extrude, just because I want to make sure that the filleting is understood a little bit better. So I'm going to take that, extrude it out, hit OK. All right, so let's take a look at a couple different things here. Basically, when you're selecting, you can select an edge, a face, or a feature. So if you select a face here, and I start to adjust it, it will automatically select all the corners there. Okay, if I select a single edge, it will only do the one edge. If I select multiple edges, it will do the same thing as selecting that entire face. And the reason for that is because, like I've said before, a face is just an enclosed network of edges. And if I select multiple edges here, and I select the entire object, and then I go to fillet it, it will fillet the entire thing, and it'll round those corners much nicer that way, if that's the effect that you're going for. Okay, so again with the filleting, make sure that you select your different faces first, then fillet. Otherwise, what will end up happening, and I'll go ahead and bring that back up here. Otherwise, what will end up happening is, let's say I select this one edge and I start to adjust it and I go, oh yeah, that 5, that's nice. Then I go to select the other one. It won't do it. If I hold Control though, I can add another one. So it's usually simpler just to get all your selections right the first time. But if for some reason you need to go back in and add one, just hold Control and then click to add them to that selection. If you wanted to do multiple different radiuses for your filleting, what you can do is you can start by, say, I select one here, and I say I want to round this 12 millimeters, and then I want to do another one where I round this side, say 6. Okay, now if I want to fillet this edge here, this new edge that's been created with these other two fillets, I have to hit OK, and then do another fillet operation to then select this edge. And is it not letting me do it? It's 0.10 as much as it can go. Should be able to go further than that. Nope, doesn't like that. How about 1? Oh, did I end up doing a chamfer somehow? Whoops. Fillet that edge. Oh, there we go. So then again, I can do that, hold control, select the other side, and get that other nice little fillet there. And that gives me that shape. So again, filleting is something that you'll be using a lot. I have a slight tangent that I go off on talking about filleting that basically is nothing in the world truly has a 90-degree edge like this box shows prior to this being filleted. The only time that there's ever a 90-degree edge like this is something that of which you will not see with your eyes. Parts that are fitting together, mechanical sort of stuff, will have sharp edges like this for better fitting and tolerancing. But if it's something that you as a user are interacting with, every edge on this earth has been rounded over ever so slightly to avoid you from cutting yourself. Sharp edges are not fun. They are not pleasant. They don't look good. And especially when you get to the rendering portion and you're trying to render, light doesn't look right when it's hitting something that has a super sharp edge like this. So there's actually always going to be a slight rounded edge, and it will totally change the way that things look, and it will automatically improve the quality of the object that you're designing. So always make sure that you're adding fillets wherever possible, especially anytime you're dealing with something that you're designing. It should have fillets on it. Okay, so let's go ahead and go back to my coffee mug here. The next command that I'm going to show is going to be the sweep. And what a sweep is a sweep is where you have a profile and a path. So the first thing I'm going to be doing is drawing the path of where the profile is going to sweep through. So probably something like that. That's pretty good for me. I'll go ahead and just leave that as is. And you can see there that that's kind of where the handle is going to go there. And one of the other things too that I'm actually going to add to that, I'm actually going to connect probably with another spline. I'm actually going to connect those together. Partially because the profile actually comes back for a little bit there. So probably do something like that. We'll just kind of see how that works out. I wonder if it'll let me fillet it. Yeah, it will. Okay. So I'm going to fillet it, but I'm going to make it a very small fillet, like 1.5. 1.5. Hit OK on that. Bring that inside a little bit more. Cool. So I just drew a loop, essentially. We'll see if the loop works. I might have to break the loop. We'll see. It depends on the profile. The next thing we're going to do, and I'm not going to talk about this whole thing as the construction geometry here. I do want to spend a little bit more time talking about it at some point, but for now I'll just explain the one that I'm going to use. And essentially what construction geometry is it's a way of letting you create geometry, specifically planes and axes and points, that you will use to make more features. So in this case, I need to draw a profile that is perpendicular to this path. So in order to do that, what I can do is I can create a plane that is perpendicular to this path. Okay. Doesn't really matter where it is located on it. So I'll just go ahead and pick a location there, hit OK. And then now I can actually sketch on my new plane, and my origin point there is on that path. Okay, so for the handle portion, I'm just going to create, I'll just start with like a rectangle here, and I'm going to basically just add in a point here, the midpoint, make that vertical, and probably just snap that to the origin. And then I'm going to make this about, try that again, make this about 7.35 by 12. And I'll go ahead and extrude it first and then add fillets. So now I've got my path and my profile, and I'll go ahead and do a sweep. It's going to ask me the profile, it would be that one, and the path is that one. And single path, it doesn't like it. Probably change that to join. Yeah, it doesn't like my path geometry there. So what we'll do to help fix that is we'll get rid of that, get rid of that, and we'll just try snapping that to that. Let's just see if it likes the points better for some reason. Looks like my feature lost its path. I'm just going to go back and fix that. And we'll do a sweep again. Profile there. Path there. Hey, that looks a lot better. And what I'm going to do here is I'm actually going to choose, instead of cutting, I'm going to join it to the existing object there. Now if you notice, I drew my path so that it went just inside of the object. That was intentional, and the reason for that is so that it will make a nice fused joint between the two. So I'm going to hit OK, and it's now giving me a warning. What's the warning about? And it doesn't like it. Edit the feature. Why don't you like it? It's doing almost, it looks exactly like I want it to, which is a bit unfortunate. Okay, so then if that's the case, what we'll do is we'll go back and we'll edit our sketch here and delete that line. Go ahead and edit this, make sure our plane knows where it's supposed to be. Go back and edit this. And have it follow along the profile. You can see there where it kind of ka-thunk stops right there. That's why you want this line to keep going. So I'll hit OK, but I'm actually going to go back and adjust this sketch. Bring that line in a little bit further. There we go. And you know what, for the sake of example, I'm not going to worry about adding in that other little fat part down here. I'll go ahead and just fill this and be done with it. So for filleting, I'll go ahead and click that edge and that edge together. We'll kind of round those to say 3.5. And then I will add another one for the inside edge. And I will round that one to 2. Sure. So hit OK there. And yep, that is that. So that is one body. And that is my little coffee cup mug there. And if I wanted to, I could assign like a material to it, take a look at what it looks like as a render. But I'm not going to do that for this one right now. So that's just a couple little examples there of using the sweep and the revolve, which are two new ones that we're looking at. What I'm going to do now is I'm just going to hide the body there. In fact, I can even name it if I want. Call this coffee cup. And I'll just go ahead and hide that, and then we'll go ahead and work on the next one, which is going to be my little paperclip holder. So I'm just going to grab some quick dimensions. I'll start with the bottom portion. And yes, I would like you guys to design all of your stuff to the proper scale that it is in real life. So highly recommend measuring everything. So 40.7. So new sketch. This one's going to be on the top plane. And I'll go ahead and do a center rectangle. And 40.7 was what I was measuring. These are going to be equal because it is a square as far as I'm aware. Yep, 40.7 by 40.7. And the height of it is 53.5. So I'll take that there, do a solid extrude. We're going to go up 53.5. Like so. And then I've got two other little features that I want to add to this. So the first one I'm going to do is I'm going to add, actually no, I'll do the first one first. So this is another one that you guys are going to be using a lot, especially when we get to our project. And what that is a shell. And what a shell is it essentially allows you to remove material from a part interior, creating a hollow cavity with walls of a specified thickness. And what that means is you use it, you click a face and you say, I want this face to have the hole in it and everything else to have wall thickness. You can see there, there's the wall thickness. And again, Fusion's really great about showing you kind of what's happening. So you can see there what's happening. If I click two faces, so I go back to my selection here, hold Control and add another selection to it. You can see there now that it is created a hole on both sides and everything else gets a wall thickness. You can keep doing this too. Again, it'll make a hole and add a wall thickness. Add a hole. At some point it gets pretty ridiculous because no one would ever do that. Most shells are just actually going to be removing one face, maybe two. So in this case, I'm removing this top face and I'm giving the whole thing a material thickness of 3.3 millimeters. Just like that. So that gives it a bottom base, and you can see there that the bottom has thickness, the walls have thickness, everything has thickness, which is just like in real life. Everything has thickness. The second thing I'm going to do is I'm going to go ahead and create a sketch on this top plane. And I'm going to draw a rectangle that is the same size as the outside. And then I'm going to do an offset of that approximately 1 millimeter in. And then what I'm going to do is I'm going to do a solid extrusion of that downwards, because what I'm doing is I'm cutting out the little spot where the lid attaches. Looks like it's about 5.5. So about 5.5, and that gives us that little bit there. And it looks like this part is actually only supposed to be 1 millimeter. which I find a bit odd considering that the whole thing is, oh, 2 millimeters. What was I measuring? So I'll go back to my shell. Make that 2 millimeters. I'm not sure why. Yeah, that looks a lot better there. Okay, so there's the bottom of my paperclip holder there. And here is where things get a little bit trickier, is I'm going to be designing the top of it. And I'm going to be designing the top of it relative to the bottom portion, but it's going to be its own body. So what I will do in order to make sure that it lines up perfectly is I'm actually going to sketch a new part here that has the same width. I'm just going to go ahead and extrude that out starting there. If you notice here, it's grabbed that edge. I want an extrude. There we go. So I deselected that other edge there, and I'm going to be doing a new body. So to not get confused with the other one. And this one has a length of 24.25. Okay, and there is the top, and I still have some more things to do to this. So the first thing I'm going to do, I'm going to shell, actually no, it looks like I need to do an extrude cut. Wall thickness is about 0.82 millimeters with a depth of 6.2. I'm going to go ahead and hide this body here. And I'm going to be sketching here. And I'm just going to kind of sketch it like I was on the other one. So same thing there. I'm just going to take that, do an offset of 0.82. And then I'm going to take this inside profile. I'm going to do a solid cut down, and it's going to go down 6 point, what did I say? 6.10, 6.12, 6.15, 6.15. So it's going to go down a little bit like that. And then now what I'm going to do is I'm going to be adding in a curve, another revolve will actually make this work here. So I'm going to just choose the plane that's coming straight through it, which I think is, we'll go with the front plane here. Now what we're going to do with this one is we're going to draw another, so the hole that's coming out the top is going to be straight, and then it curves back using something like this. Basically something like that. I'm going to go ahead and make sure that this and this are tangent. And I am going to go ahead and add in a center line right there. And I'm trying to currently snap this to the object, but it's not letting me. It's giving me grief. All right, so let's just take this point and our origin, make them vertical. Let's take that edge. I'm going to click that edge, hold Control, click the point, make them coincident, point, edge, coincident. Perfect. And our top hole is about 23 wide. So from here to here, it's about 23. And then the bottom, ooh, is almost the whole thing. It's gonna go just short, probably about 35.5. So from here to here, it's about 35.5, which is about just shy of that edge. And this curve here is just going to be whenever I determine to look correct, which is probably something like that. And that I'll snap to there, and that I'll have to hold control, and I'll have to try to select try to select that edge, make those coincident. If you have no idea what I just did there, essentially what I was doing is I'm trying to take that and that edge there, we go, and make those coincident. Okay, that looks pretty good there. And what I'm going to do is I'm going to finish drawing this out by drawing a straight line, straight line, straight line like that. I'm going to do a solid revolve, and this time I'm going to be doing a cut on this one. So I'll hit cut and I'll hit OK. That gives me that nice curvy geometry that I'm looking for. That looks pretty dang spot on, actually. All right. And because this object was designed in the 1970s, it actually has 90-degree corners. I kid you not. So I will leave it authentic. Looks like one of them has been rounded over naturally over time. The other three edges are actually quite sharp. I'll go ahead and show the bottom portion of it there now. And that's my little paperclip holder there. Technically, there's a couple other elements to this. There's actually a magnet inside of here. There's a split in the plastic here where the bottom body attaches to the top body. But for the sake of this first assignment here, I'm just looking for simple geometry here, something like this, to get you started. And this one we'll call the paper clip holder base and the paper clip holder top. Okay, so there we go. I've got my two objects. There's 1 and 2. And that is what I'm looking for your guys' assignment exercise for this week, is just to design 2 simple objects using this myriad of simple design tools that I've showed you guys, as well as using sketches. Again, to reiterate, some of your sketches will not be fully defined, especially if you're using things like splines. That's okay. But if you're not using splines, they should be fully defined. As you can see here, everything that wasn't using a spline is fully defined, and everything that is using a spline is still shows not fully defined, which is okay. And I'll be sure to look at those closely. Okay. So the last thing that I wanted to talk about is your project, and your project is going to be to design a desk. And I will be submitting the prompt online, and we'll talk about it on Wednesday. And basically, it's going to be to design a desk, whether it's based on something that you have used in the past, or it's something that you could see a use for as a desk. But basically, it needs to be a little bit more than 4 legs and a slab top. You need to put a little bit of time into it in actually creating a interesting, unique desk, something that has a few features. We're looking for features like drawers, shelves, cutaways, different sections, whether it's a curvy desk or not, things like that. And all of this will be done in a single component like shown here. So essentially, in the example of my paperclip holder, I've got the two objects here. That's exactly what we're looking for, is those two objects interacting with one another within the same component program here, your same component document. So just to show you quickly on what I'm meaning by that, if, for example, here I was to draw my legs of my table here, and this isn't going to be perfect by any stretch of the imagination, it's merely just an example. I'm saying don't do this, and then here I am doing it, but essentially, you know, here's my forelegs, and then I'm going to draw on top of that, creating a sketch, and I'm creating my tabletop. This is what I'm meaning by creating it within the same document. That's really all I want to get across. Oops, and I just goofed right there. Edit that feature. Instead of doing an operation join, it needs to be a new body, because these are two separate bodies. So this is the top, and you can see there, and each of those legs you can see is its own body as well, which is great. That's what we want to see. And then that there is its own body. And one of the things that I was going to show as well, just real quick here, is like if I were to create a drawer, and again, I'm doing this fairly quickly, and if you need to come back and review this, definitely do so. But the way that I suggest you guys do drawers is to essentially create a box, probably just something like that. It would be fun to see some hardware as well, but if it's a drawer, it's just going to be an extrusion like this. It's going to be a new body, and then you're going to want to shell out the front, give it some material thickness, and this is not to scale whatsoever. Your desks will definitely want to be to scale, and then you'll want to create a new sketch of the drawer itself, and I would just say kind of reference the hole there, maybe take that and offset it by like 0.5 millimeters, or actually that, I mean, in this case 0.5 is actually not going to be a big gap, but in this case of this example that I'm drawing, it's a big gap, but it won't be when you make it real sized. And then this, you'll want it to go all the way till it runs into the back of the drawer, which in this case I made it a little bit too long. And this will be a new body as well. And then this body, go ahead and hide the other ones. You're going to want to shell out the top of it, and the top of it will give you the inside of the drawer there, and you can see there of kind of how that works. So I've got the front of it, and then I've got the drawer on the inside. I'm not looking for you guys to go in and, you know, add miter joints and split everything up into different pieces of wood and show exactly how all the construction goes together. What I'm looking for is if you were to come up with a concept of a design of a desk, and to the best of your ability design that. And again, I'll talk about this more on Wednesday, but that's the biggest thing, is just kind of showing you quickly there how I design and how I'd recommend you design the drawers. Definitely add some sort of cutout for a handle, or actually model a handle to go on the drawer. That is preferred. And of course, your insides you don't really need to fill it, but your outsides you probably should fill it to some extent. And right up here where the desk meets the drawer, you won't fill it, because again, that's like where you would add glue, and that's not something you're interfacing with. But if you were to bang your leg into any of these, you'd want all of these filleted. So just keep that in mind. Hopefully this makes sense, and do let me know if you need some more help or instruction regarding this. And the quiz as well, just one other note, the quiz is open program, so you can use Fusion to get your answers for that, and then be able to fill that out. All right, so with that being said, have a good rest of your week.